In the first part of this lab, we are going to be installing some equipment here on these two needle valves on our electrical and tubing trainers here. These are two needle valves we have here installed on the 2-inch Schedule 40 piping down here. And I'll just take you over here to point those out. I've drawn up a small little piping and instrument diagram here. The needle valves have these symbols right here, and this is our orifice or restriction on the 2-inch Schedule 40 pipe. We're going to be installing a manifold. It's represented by, we have these 5 valves here and this dashed line that represents that they're kind of all in one piece of equipment. And that is this right here. This is our 5-way manifold that we're going to be installing. I've also noted here we're going to be using tubing in this lab to install the equipment. So these lines here, all these solid lines here, except for the stuff inside the dashed line, but this line here, this line here, this line here, and this line here, are all going to be made up of 3/8 inch. So that's the OD of the tubing, and the wall thickness is 0.035 inches, or 0.35 wall is what is commonly used for a term in industry. So on the piping instrument diagram, it should state the size of both piping and tubing lines to be used for installing the instruments. Up here is an instrument, and it has been it's got using the nomenclature PDG. These identification letters are used to indicate what this instrument is going to be doing. And the instrument is right here. It's a gauge. You can see right here, a differential pressure gauge. You can see down here it says differential pressure. So we're going to be using this to measure the differential pressure across the orifice plate here in the line. Just to show you where these letters come from, I've got the standard, one page from a standard, ISA 5.1, version 2009. And this is about a 150-page document, but I pulled out this table here because this is where the identification letters come from. You can see table 4.1 identification letters. Up top here we have our first set of letters, and then we have our second set of letters. So our first letters are the P and the D right there, and they're usually used to kind of identify what the device is used for measuring. So let's go down to P here. So P is pressure. And if we need to indicate any more details, which we do here because this is a differential pressure gauge, we use the D over here for difference. So we'd first write P, then D, means we're measuring a differential pressure. And then this line here kind of divides into our succeeding letters here. We have our first letters and then our succeeding letters. Our succeeding letters we need to use to indicate if it is an alarm, a sensor, what else do we have on the list? A switch. There should be one for valve under V, a valve, right? So this here is a gauge, so we would use G to indicate that it's a gauge. So that's where those letters come from. I wanted to point that out because this table is very commonly used with piping and instrument diagrams, mostly for the instrument part, to indicate the function of an instrument. So this equipment over here, we're going to be using this equipment right here to complete the task. We already have our needle valves installed, so we don't need to install those. I've also saved some time by installing these 3/8 tube fittings by 1/2-inch NPT tubing fittings. They've already had the Teflon tape applied to them, and they've been tightened into the manifold to save some time. But the fittings that I have not installed are the ones that are going to be going on the differential pressure gauge, and those are these fittings right here. So I have all the nuts that we require for the lab. We need 8 nuts. We're going to be, when we're done with the lab, we're going to be cutting the nuts off the tubing and reusing them for the groups to come who are going to be performing the lab after. So with each one of these nuts, we need to have a ferrule installed in them, and so all of the nuts will need that installed. I left them out. Usually when you purchase a fitting, the ferrule will already be installed and the nut will already be on the fitting, but I wanted exposure to that so we have the ferrules installed correctly. So what I'm going to do is I'm going to get a ferrule installed on one of the fittings so I can show how a ferrule should be placed in these nuts. Alright, so you can see I've installed the ferrule inside of the nut here. I've dropped it in there, and there's two parts to this ferrule. There's a smaller piece and a larger piece. This is what they call a compression fitting, because when you tighten the nut down, this ferrule compresses onto the tubing, creating the seal. So the bottom piece here, this is the smaller of the two. It's placed in the nut first. You can kind of maybe see a little bit of it down there, but the larger piece is sitting on top. So this needs to be placed. If I just bring this in closer, we want to make sure that the larger part of the ferrule, or the lip there, the back part here, it is down like this, and then the larger part kind of sits on top, just like that. And you can see here these are all in that same position right here. You can see that the larger part sits on top just like that. And so when it gets dropped into the fitting, into the nut, sorry, we want to be dropping it down like this. So it looks something like that. So I'm going to go ahead and install all of the ferrules in these remaining nuts. Alright, so you can see all the ferrules are in the nuts. And I really want to stress the importance that they go in the right way. So they're going to be dropped in like this. If they're not installed correctly, they will not provide a seal. They won't work, they won't function correctly, they won't compress correctly, and we won't have the correct seal that we need for our tubing. So the next part, we want to make sure that these fittings, we want to place these fittings, we want to put them onto a nut here. So I'm just going to go ahead and put them on for both of these as well. And so if I just thread this on, I'm using one hand. Let's turn this upside down again. Oops, I've got it the wrong way, that's why. There we go. So now we have nut and ferrule installed on both of these fittings. The next thing I want to demonstrate is putting the Teflon tape onto these fittings here. It's very important that we put Teflon tape onto these fittings. It kind of helps a little bit with the sealing, but also importantly, it lubricates the threads, the Teflon does. So then if we ever do, you can see here, we're going to be threading it into right here. If we ever do need to remove this fitting, we can. What'll happen sometimes is if you have stainless steel on stainless steel, or two similar metals, they'll kind of gall together, and then when you go to try to loosen the fitting off, they kind of almost become one. They kind of mash together, and you won't be able to get this fitting out. Putting that Teflon tape on will help prevent that from happening. So I'm going to go ahead and put some Teflon tape on this fitting. Alright, so I've placed this fitting in the vise here just to help hold it for myself. This Teflon tape, you want to always tape it on when we're looking at the fitting like this, when we're looking at the threads, we want to make it go clockwise. We always want it to be clockwise, going clockwise around the fitting. If we do not do it that way, then when we go to thread the fitting into the gauge, the Teflon tape will then just come off. It'll unwind almost. But if you tape it on clockwise, it's kind of going with the threads. It's going to be threaded on the same direction that we are going to be threading the fitting into the gauge, and it will stay on. So we want to make sure we have it taped this way, and we give it about 2 wraps. So I'll go ahead and do that. Alright, so I've taped it on, and I just had to kind of pull the Teflon tape off to break it loose. I gave it 2 wraps clockwise on the fitting, and now it's ready to be installed into the gauge. Alright, so I've got this in just hand tight here, you can see. So this is what I was talking about. Now that we're turning this in, we're going to be turning this in clockwise. Since we put that Teflon tape on clockwise, it's going to stay on. So I can go ahead and just hand tighten this, and then I have a 5/8 wrench here we're going to be using, and just wrenching right here on the fitting and snugging it in to place on the gauge. Alright, so now I'm going to go ahead and do the other side as well. Alright, you can see I have both fittings installed on the differential pressure gauge. One other thing I wanted to point out, if you are using the vise to install these fittings, make sure that you're clamping down on the gauge part here, not on a nut on the other fitting, because we want these to remain nice and loose or hand tight. If we were to say clamp right here when we were threading this fitting in over here, what would have happened is we would have actually tightened this up as well, and that would we want to leave this nice and hand tight, so when we go to actually install the tubing here, we are going to be doing this as well. We're going to be checking to make sure it's hand tight, because that's kind of our reference point for where we start tightening the compression fitting, and it's kind of key that we need to leave this hand tight. We don't want to start tightening down on those furls ahead of time or too early. Alright, you can see here now I've installed the nuts on our manifold here as well. This is called a 5-way manifold, and it represents all 5 of these valves here within these dashed lines within this box on our piping instrument diagram. So our next step here is to start tubing in the differential pressure gauge into the top of our 5-way manifold. So we're going to get started on doing that. So you can see here I have selected some tubing here. You can see that it's stamped right on the tubing here. It's 3/8 inch, and that's the OD. So if you measure the outside diameter of this, it should be exactly 3/8 of an inch, and the wall thickness is 0.035 inches. That's the thickness of the wall, and that has to do with the pressure rating. So this is the tubing that our piping instrument diagram said to use, so that's what we'll be using. It's also important to note some of the tubing, this is all the tubing that we'll always have in the lab for 3/8, but it'll have this wall thickness. But over time, if this tubing gets rubbed around a lot, this printing can be rubbed off. So if you were working out in the field and you didn't know the wall thickness, you may need to use a vernier caliper or something like that to measure the wall thickness to ensure that you're using the correct tubing. Alright, so you can see I have some tubing installed in a set of our Swedgelock tube benders here. Some things that I wanted to point out. One of the real important things here for ensuring that our tubing will be able to install into our fitting correctly is to ensure that we have the required straight tube length for the tubing here, because if you look at this diagram here, L here represents the required straight tube length. We need to make sure that we have enough straight tube length to go into our compression fitting here, so then when we tighten this down, our nut and furl isn't trying to clamp down on crooked tubing, right? We want to have this nice straight tubing going in. And I wanted to point out how the benders, there's a reference mark right here on the benders right there. You can see that mark. And the tubing, when we're bending our tubing, we want to make sure that that tubing at least makes it to that reference mark, because if it does not, then we won't have the right amount of required straight tube length here, and we won't be able to install the tubing on a fitting. And you can see here they have it for the tubing OD for different sizes of tubing, and we're working with 3/8 here, so that means our L needs to be at least 15/16 of an inch or close to 1 inch, right? And so when we do make our bends here, we can maybe check that out, but I really wanted to point that out. I wanted to point out that the tubing needs to be at least to this reference mark. So the next thing I wanted to point out here on the tubing benders is we have a few things. If we're bending a 90, so if we're going to be bending this tubing down to 90 degrees right here, the reference mark that we're going to be using on the benders is this L value. And L stands for left and R stands for right. Left being, once we make a bend and we move our tubing out to the left, this is going to be our reference mark. And so when the tubing is bent, the center of this tubing right here is now going to be along this line here for L. So that comes into play when we're making a lot of our measurements, and we're going to demonstrate that here right away. So what I want to do is we can measure from this reference mark out to L, and just see how far that is, and then we'll make our bend and just prove that we'll make that same measurement again after we've bent it, and prove that the center of the tubing now is running parallel with that line for L there on the benders. Alright, so you can see I've bent the tubing now. I brought the 0 mark, which is right up here at 0 when we first started. I brought it down to line up with 90, and now we've bent a 90 degree in our tubing. Also, you can notice here that this latch, you can see a little bit better now, that needs to be clamped down onto our tubing, obviously. If we don't have that clamped down, then the tubing will not bend. So that had to have been done before, and you would have seen that. Looking back, you would have seen this was clamped down onto our tubing. So we've bent that 90, and now we'll go and take two measurements here and just check to ensure that, like I said before, that where the L was up here, the distance from there to the reference mark is now the distance from here to the center of our tubing. Alright, so I have the tape measure lined up at the reference mark over there, and if we look at the L, which is right up top there, from the reference mark to the L, and the L is the last tick on the line, it's about 2 7/8 of an inch there, you can see. Or sorry, not 2 7/8, 1 7/8. 1 7/8 of an inch. You can see we're lined up with the 1 7/8 of an inch line and the reference mark. So when we do our bend over here, I left the bend, it's right here, you can see that from that reference mark to the L, the center of the tubing is going to be at 1 7/8 of an inch. Right, so I know our initial plan was to install the gauge first, but after bending our 90 there, I figured we'd make use of it because we will need a 180 degree bend for our gauge, but I thought I'd make use of this 90 rather than just cutting it off. And what we're going to be doing is we're going to be installing our 5-way manifold here first. So what we need to do is we need to take the tubing right here and bend it up at a 90 degree bend. Our goal here is to try to position this 5 valve manifold right above and centered with our orifice plate there, our flanged orifice plate. So what we're going to do is have to make some measurements. We'll make the measurement between the two needle valves, and we're going to center it between those two needle valves, our 5 valve manifold. Okay, so what we're going to do is we're going to measure with tubing. We're usually dealing with a center to center measurement, so the center of this fitting to the center of this fitting. We want to measure the center to center measurement between those two fittings and divide by 2, because we want our manifold, 5-way manifold, to be right in the center here. Divide by 2, and then we're going to take a measurement on the manifold to figure out where the fitting is and figure out how much further over we need to bring that. So when we do make our bend, we come right up into the bottom of that fitting. So I measured this at 8 1/4 inches. I'll just kind of show you how I did that. So we could place it right in the center of the fitting and go over, and you can see the center is about 8 1/4. Another way to do it is if we measure outside to outside of the fitting to the outside of the nut on the other fitting, and you can see it's at 8 1/4 inches between those two. So we have that measurement. Now we need to go over to our manifold and get the measurement. So we had our measurement of 8 1/4. That means we need to come over at least 4 1/8 of an inch, right? We divide that by 2 to get to the center right here. But we also need to take even more off of that, because we don't want to come up to the center of the manifold. We want to 90 up into this fitting right here, right? So let's measure the center of that fitting to the center mark, or the center of the manifold. It looks like it's about 1 inch. We need to take off the 4 1/8, so we're at 3 1/8 of an inch. So we want to bend up our 90 at 3 1/8 of an inch. Alright, so you can see I've used a Sharpie marker to mark where I'm going to be doing my next 90 bend on my tubing. I'm holding the tape measure. It's at the center of the tubing, over to where we want the center of the tubing to be after we make our 90 bend. So you can see I've marked that. We'll pull this out and so one feature that I like of the Swage-Lock benders, you can see here they've got a little block on the end here that we can actually clamp them into a vise to hold them into place, so I can just kind of set them up, get them ready for the bend. I've got my latch pushed down here, and you can see that I have the L, because that's what we're bending, is a 90. We're going to be bending a 90. If we were bending a 45, we would be here. If we were bending a 30 degree, we'd be here. For a 15 degree bend, we'd be here. But since we're bending a 90, and you can see that our last bend here is on the left, we use the L. If we had the tubing flipped around the other side and this bend was over here, we would be using the R to make our bend. So we got the right measurement, right? Because from the center of here to the center of where our tubing is going to be bent is going to be 3/8 of an inch. If we wanted it to be that same measurement, but we had this bend over on the right side, we would need to use the R for bending, lining this line up with the R for bending our 90. About 100%, well not 100%, about 90% of the time the L gets used for bending the 90s. We usually always use it out to the left. The R is sometimes used for tighter bends. But anyways, so I have this lined up. We want to make sure that this here is completely parallel with our bender arm here, right? So we bend this, this bend gets made straight up. As long as this is lined up correctly, right, and that our bend is going to go the right way, that if we had this flipped the other way, then we'd be bending it straight back down the same way. We don't want that. We want to bend it so it comes up into the bottom of our 5-valve manifold. So now I'll go ahead and make this bend. So yeah, just before I make the bend, I just wanted to point out that you can see that the tubing here is pretty parallel with the handle back over there. So it's gonna when we do this bend, it's gonna be going straight the other way. It's gonna be going completely opposite of this. It's gonna be going straight that other way when we've completed our bend. All right, there you can see now that we've made our bend, and the 0 mark here came down to the 90 there, and now from the center of this tubing to the center of this tubing should be 3 1/8 of an inch. So now the last step we have to do is take it over, and we're gonna need to cut our tubing with some tubing cutters, so then we can put this chunk of tubing in for our 5-valve. Right, so I have the tubing installed. We're gonna be cutting off some of the tubing. We're gonna make sure that we have enough of the straight run for our tube fitting, but really the height of this, that's probably going to be the deciding factors. We want to make sure that we have enough of the straight run tubing here. We don't want this too high, obviously. We want it to be probably about chest height or whatever like that. So we'll just nip it off and make sure we have enough of the straight run. Alright, so what I did was I just measured from the outside here of this tubing to the end here, and then I did the same over here. I measured from here to there and marked it, and you can see that I have at least 1 inch of straight run here for our tubing to go into our next tube fitting. So we'll go and cut at this mark right here. So we have our tubing placed in the vise. There's our mark that we need to cut, and we're going to be using these rigid tubing cutters here. So we'll just thread these out, place them onto the tubing, and we just want to have that, you can see the cutting wheel there right on our mark. Looks pretty good there. And what we're going to be doing is snugging up the handle here, and then just turning it, giving it about 2 turns. You'll feel it loosen off. Turn the handle probably about 1/4 or 1/2 turn, and keep doing that. Tighten it again. Keep doing that. Keep turning it, two rotations about approximately, and then tighten it again until eventually the tubing cuts and falls off. Alright, so after we've cut the tubing, you can notice here there's kind of some sharp edges here, what they call burrs. So what we want to use is a deburring tool right here to remove those burrs. And this deburring tool we always use from the bottom here, because what it does, this cup here collects the burrs as they're knocked off. That way they don't collect inside the tubing here and plug off small ports and instruments. So I've just positioned it in the vise here. What you want to do is just turn it back and forth like this, and as the burrs are knocked off with the deburring tool, they will collect in the bottom there. There's a few of them collecting, and then once you've done a few chunks of tubing, you can empty out the deburring tool. So there's a part here for doing the inner part of the tubing, and then I'm probably going to lose some of my burrs here, but there's also a part here for doing the outer part of the tubing as well. So we would do both. Usually the outer part doesn't have very much for burrs, but I'll do that as well. And then we'll take it out and have a look at it. So there you can see, here's the end that I've deburred. I've deburred both the outside and the inside of the tubing. If I just flip it around over here, this one here has not yet been deburred, and you can see that there's still some sharp edges there, especially on the inside part, that someone could maybe cut their fingers on. So we want to make sure that we remove those on all ends of the tubing when we're doing when we're installing our tubing. So I've placed the tubing in. I haven't tightened the nuts yet, but just to kind of do a quick visual check, it looks like it's going to put us pretty well right in the middle of the 2 needle valves. Once we get the other piece of tubing in there, it'll support it as well, because when I let go of it, it kind of sags off to the side there. But what I'm going to do is I'm going to tighten the nuts for here and here, so this piece of tubing is then complete. The next piece here, we want to be sure that we're measuring to make sure that we've got this measurement correct, just in case we aren't perfectly centered, but we should be pretty close to being centered, and we can basically should be able to build an identical piece here. Alright, so for tightening the fitting, we need to make sure we insert the tubing. You can see we want it to bottom out, so that's why that straight run is so important. And then we're going to mark the nut. I'm also going to mark the tubing because it says to mark it at the 6 o'clock position. And then while holding the fitting body steadily, tighten the nut 1¼ turns. So what we're going to do is we're going to take it from that 6 o'clock position and go all the way around one time and then 1/4 turn. So you can see they have the two wrenches there, one backing up the fitting and then the other on the nut. And this is for all fittings up to 1 inch. There's also another note down here stating that for 1/16 inch, 1/8 inch, and 3/16 inch tubing, we turn the nut to the 3 o'clock position, so 3/4 turn only. But most tubing is pretty 3/8 is very popular, so probably the 1 1/4 is going to be one of the most commonly used ones if you get into doing a lot of tubing. So 1 1/4 turns is what we use. So I've got the tubing here installed, and I've tightened this to finger tight, and now I just need to go and mark the tubing before I use the wrench. Alright, so you can see I've got the two, a mark on the nut, a mark on the tubing, so I know that I've gone 1 1/4 turns. I have an 11/16 wrench here and a 7/8 wrench on the fitting body here just to back it up, so I don't once I start tightening this, I don't want to start moving the fitting because it's already been taped and installed. We just want to make sure that we're holding it in place. Alright, so you can see that I've gone around one time, and then I've gone past the mark to 1/4 turn here, so 1 1/4 turns. What I have right here is it's called a no-go gap gauge. And this is used to ensure that we've tightened it enough. We're using 3/8 tubing here, so when I go to try to stick this in, it shouldn't go in. Whereas we look at this fitting over here, and you can see that it can fit underneath the nut, but over here it cannot. And that's just to check to ensure that we've tightened it enough. One other thing that's kind of neat to see on the back here, they've got it stamped right on here, 1 1/4 turns from finger tight, just to remind the user that that's how tight or how many turns we need to make on this fitting for it to seal properly, and for the no-go gap gauge to indicate that it's been tightened properly. So I loosened this nut off here now with the wrench, and just wanted to pull this off now, and just to show you there, you can see that's what the nut and ferrule is now compressed down onto the tubing, and you can see the tubing is slightly bulged there as well. So it's very important. If we didn't have enough straight run, this tubing here, there might not be enough here for it to bite down on, and we want to make sure that that tubing is seated right down on the bottom of the fitting, right? So this here has been done correctly. We can install it, and basically now we just need to tighten the nut back down. You can see I can get just past one turn now. If I just use the wrench here, I can snug it right back up to that, give it that extra 1/4 turn that's needed, and now it's installed back properly. So the nice thing about these compression fittings is they can easily be removed if we need to service a piece of equipment or anything like that. They're pretty rugged, and but yeah, it's very important that we have enough of that straight run, and of course that the threads and everything are clean enough dirt and stuff in there. We don't want it, none of that would could cause leaks and things like that, so we want to make sure that they're nice and clean, and that we follow 1 1/4 turns and enough straight tubing into the fitting so it can compress down onto it, compress the furls down onto the tube. So one other thing I want to point out before I install the 5-valve manifold, this nut and ferrule I was able to set just by using this fitting down here. So sometimes it's more convenient to use a fitting. I got to tighten this still, I see. Sometimes it's more convenient to use a fitting that's nice and easy to work with. It's kind of held in place already, right? Whereas the one over here on the manifold might be kind of tricky because the manifold's kind of loose unless we threw it in a vise or anything like that. But I just wanted to point out that you can set these fittings in any other fitting. They're interchangeable now. I can go and install this on the bottom here of the 5-valve manifold. So just before I go and cut my second piece that I built here, I wanted to make sure that when I actually do cut it, that they're going to be the same size. So just lining that up at that end, and let's just see here. Everything looks like it's lined up. And then there you can see I made my mark. So I should be cutting it so it's the same size as this other piece so that our manifold's nice and level. So yeah, I'll go ahead and cut that. So the manifold's installed. I'll just quickly use the no-go gap gauge here and just check to make sure that I've tightened all of my fittings. And yes, so it won't go into any of those fittings, so they're all tightened. Also important to note the orientation here, just as it was drawn on the piping instrument diagram. We're going to be coming into the bottom here of the manifold, right? And then these fittings are the top, and they go out. They go out to the top, they go out to the gauge. So you can just see here, this isolate valve here and here represents this valve right here and right here, and then this valve in the center represents this right here. These two up here are equalizing valves. These arrows are pointing up to go out to the instrument, you can see. So we've got it orientated right. If it was upside down, then all this writing and stuff would be upside down, and it would be installed upside down. So now we're going to be tubing this gauge in. The plus side on the gauge over here on this side needs to be upstream of the orifice. So if you look down here, we have an orifice plate here in the line. It's a restriction, about 1/8 of an inch diameter, and when gas flows across it, it's going to create a higher pressure upstream because we have that restriction, and a lower pressure downstream. So looking at our gauge here, this plus means to represent the higher, the more positive pressure. So usually, sometimes it'll be also indicated with an H for high and an L for low side. So we want to make sure that this line, and it's nice and convenient because we can run this line up and into our gauge. So that's what we're going to do. We're going to bend 180 degree bend, and then we're going to 90 down into our fitting there with the gauge. So let's have a look at how we do that. Alright, so we're going to be making a 180 degree bend now. I've got the tubing at our reference mark over here. 0 on the top half lined up with 0 on the bottom half. And we're going to be bringing 0 all the way around to 180 degrees to bring this tubing, to bend this tubing in 180 degrees for our first bend. Alright, so I've bent this around. Tubing has a 180 degree bend in it. One thing to note with these benders, the handle here threads out. So if you do need to reposition the handle to make it easier for bending that 180 degree bend, you can by threading the handle out and repositioning it, this top handle. Alright, so the manifold is exactly 4 inches wide. So 2 inches being the center. If we put the tape measure at 2 inches there, you can see. And what I'm trying to get here is a measure from the center of this tubing fitting. And it looks like the center of the tubing fitting is about an inch, maybe an inch and a 1/16 to the center. And the reason why I need that is so we can position our gauge so it is centered with this manifold. So I'm getting the center of the tubing fitting at about an inch and a 1/16 from the center of the manifold. So we're looking at from here to the center of here at about inch and a 1/16. So with our piece of tubing with a 180 degree bent in it, I've placed it in the fitting. I want to make sure that it's all the way in the fitting. What I've done here is I've marked, I want to make sure that we have it in all the way. I've marked it just to indicate the bottom, that it's bottomed out, and you can see now that I have it all the way in there. And what I want to do now is I want to position the tape measure at about the center of the gauge. So right about there, or about center. This little mark here on the gauge is the center of it. And we're going to bend it at 90 down into that top fitting on the manifold at about an inch and a 1/16. We're just past an inch there. So we'll mark that so we know where to bend our 90 degree bend. And then we'll go ahead and bend it to make the bend. Alright, so I have the tubing in the benders, you can see. The L's lined up with our mark. And we just want to check to make sure that the 180 degree bend is straight up and down. It looks like it is, so we can go ahead and make the 90 degree bend. And there, I've made the bend. I've brought the 0 down to the 90 degrees. So we can now measure and cut off what we don't need. So there I've cut off, after we made that 90 degree bend, I've cut off the remaining tubing, and you can see I've left at least about 1.5 inches of straight tubing, so that'll be good enough for our fitting on the manifold. All right, and there you can see now that with the tubing, I haven't tightened these fittings yet, but I just wanted to do a quick check to make sure that our gauge is centered with our manifold. It looks like it is. So what I'm going to go ahead and do now is I'm going to build another identical piece of this tubing here for the other side, so we can install the gauge. Alright, so I have all the tubing bent there. You can see now I've got 2 identical pieces. I would maybe suggest you can kind of take this apart and do set each of the tubing fittings individually, just because if you have a look here, the one tubing is slightly shorter, right? And we want to make sure that this tubing here is all the way down. It could have to do with the spring back on our bends. The bends, after we bend the tubing, might spring back slightly. Could be that I've slightly cut one of these shorter than the other. But you see, you want to make sure that this is all the way down into the fitting before we tighten up, do our 1 1/4 turns on our nut. So I'm gonna take this gauge out and do each one of these individually, just to make sure that they're all pushed down and set properly. All right, so I've set all these now. I've done a 1 1/4 turns on all these nuts, and I was able to hand thread all of these nuts back on except for this one here. And if you look here, it's kind of not quite square. So there, I kind of pushed it in, and we'll see if it threads on. There, it seems to be threading on a little bit better now. But what I wanted to point out is, if you do run into an issue where you're putting these back on and they don't want to go on with your hand, don't use a wrench to try to tighten them on when you're just starting them on. What you can do is cross thread these threads and wreck them. So you want to make sure you get the first 3 or 4 threads on with your hands. If you can't, you may have to loosen a nut off maybe down here, so then you have some more wiggle room over here, and kind of wiggle the might have to kind of wiggle the fitting. And there, now that I was able to wiggle it, I was able to get a few threads started. As long as you have a few threads started, then you can use your wrench. If you do not, you will wreck the fitting, wreck the nut, and you'll have to completely redo this piece here, because you have to cut the nut off and all of that. So this is very important. Avoid cross threading your fittings. So the best way to do that is to make sure you can get it on with your fingers before you start using a wrench. Alright, so next up we're going to be hooking up some air here to flow through our 2-inch pipe and see if we can create a differential pressure across the orifice plate we have in the line to see if our gauge reads a differential pressure. Right now it's sitting at 0. But we need to know how this 5-valve manifold works here. So as long as these 2 valves here are open, the 5-valve manifold, if you look on the diagram here, we've got a valve here and a valve here. Those are the 2 valves on the outside which have isolate on them. So if we were to close those, it would isolate these 2 lines right here. The valve in the middle is probably has vent labeled on it. Yes, vent, and it is used for venting. So if we were to isolate here and here, shut these 2 valves, and we were to open the vent here, it's going to bleed off any gas in the manifold. And of course we need to have our equalizer valves, this one and this one right here, open as well. So we shut this one, the 2 isolation valves. As long as the isolate valve, or the equalizer valves, which are right up here, and they should say equalize on them somewhere. You can kind of see it written there. Equalize. They will equalize both sides of the gauge, the high and the low side, right? And so the pressure will be equal on both sides. So once those are open, then if we open the vent valve, it'll bleed off all the pressure. So if we did ever need to replace this gauge or anything like that, that would be the procedure to do it. Close our isolator valves, open our equalizer valves, and then open our vent to bleed off any of the pressure, right? And then once the gauge is installed, now we would shut our vent valve first here, so this is closing it clockwise, and leave both of our equalizer valves that are closed. Let's open those. Have them both open. So our vent's shut, equalizer's open, and then now we can open our isolation valves and pressure the whole system up. So we would open these 2, and once these are open, they will stay open when this is in service. We could shut both of our equalizer valves. And then normally we leave the vent open, just so then if one of the equalizer valves is leaking, then since it's instrument air here, we just have this vented to the room, we could then hear that there's a leak. But sometimes if this gas is toxic or isn't air and it can't be vented into the room, there'll be a line connected into here so that it is ran to either flare or somewhere where it can be disposed of properly. So during normal operation, equalizer valve shut, vent open, and isolation valves open. So then with these two closed, it's going to just allow gas to come, or air to come to this side of the gauge and this side of the gauge, so that we can sense our differential pressure. So now that we've got this set up and ready to go, I'm going to hook up air, and we're going to see if we register a differential pressure across. Alright, so now that I've connected instrument air over here on the back side, I have air coming in, going through this regulator, opening our control valve at the bottom here, and then air is flowing out the bottom. And if you look at our gauge here, we're registering a differential pressure of about 25 kPa, or about 25 psi, or about 175 kPa on the differential pressure gauge. So it was plumbed in right. If we had these tubing lines switched, we'd be reading a negative pressure. So this has been installed correctly. All right, now for our cleanup, we're going to disassemble all of this and cut off all of our nuts off of our tubing to reuse them. But these fittings on our manifold can stay. The fittings on the needle valves at the bottom there can stay. But we will remove the 3/8 tube by 1/4 inch NPT threaded fitting here on both sides of the gauge. So we're going to go ahead and remove all of that now. So when we're all done with the tubing, we're going to want to cut off these nuts here to reuse them. You can see this here bend. We've got a 90 right here close to this nut. So using tubing cutters won't work very well there. So what I would like for when we are cutting off these nuts, we'll just use a hacksaw and we'll cut the tubing right close to the nut. So we can do that for both of these here. Cut them off with a hacksaw. Of course, we won't be able to reuse the furrows in here because they're compressed onto the tubing. So we'll be cutting the tubing here, and then we can remove these nuts and reuse them. Whereas the tubing and the furrows and the scrap chunks that we cut off, they're going to be discarded in the metal bin. So there you can see I've cut this off with the hacksaw, and here's the other side here. You'll notice that it does want to kind of stay in, so we may have to kind of slightly push on it here with the tubing, other side of the tubing, to kind of work it through. And there you can see it's kind of pushing through. May have to take the tubing out of the vise and push it further, and then oh, there we go, and then it should just fall out, and there you have the nut ready for reuse. Right, so after disassembling all the equipment, we should have the differential pressure gauge with the tubing fittings removed. You can see I have them sitting right here. Most of the Teflon should just peel off. I do see I still have some left here. If you can't get it all off, you can take a wire brush to it and just kind of clean that up so all the Teflon tape is off. This one here, all the tape came off, you can see. And then 8 nuts and the 5-valve manifold, and with these fittings left in them. All the fittings can be left in the 5-valve manifold. And all of your scrap tubing left over from cutting the nuts off will be thrown in the steel bin and recycled. One other thing I wanted to point out is the measurements between these two needle valves. Center to center measurements that we made earlier in the lab may be different on every trainer, so you will have to make those measurements on your own for your tubing bends to be correct. So make sure you make those measurements for the lab yourself.